one last speaker, Jennie Hansen from Heriot-Watt University, is going to talk about no more model tutorial solutions.
Okay, I've managed to successfully unmute. Okay, yeah, no more model solutions. So this is what I've tried this semester. Let me tell you a little bit about it. So the context here, I teach a first-year probability theory course, and any of you, I am a probabilist, and basically compared to some other things that you might encounter in first-year mathematics, probability is really just almost exclusively problem solving, because you have some tools, but there are just so many different problems that you can set. And one of the things that I want students to be able to do is to be able to feel confident that they can solve problems. And that comes from being able to explain your answers, explain your counting, justify your probability calculations, make reference to definitions, propositions, theorems, etc. Well, you know, it is hard for students. It's always, they come from school, and even if they've seen probability and statistics in school, they've not really seen it in a way that I think challenges them as much as perhaps they can be challenged to solve problems. And so it's challenging. They have to get used to not expecting to know immediately how to tackle a problem. It's not like being drilled in things like differentiation or integration, where, you know, after a while, you know, I can just look at a problem and I know how to integrate it because I know there's a way to tackle it. And it requires perseverance, because you do get stuck, and that's something that is a little bit hard to live with, as we all know, because we've spent our lives having to persevere, proving theorems, etc. And of course, you can't actually learn to solve problems or to write a reasoned solution by reading a model solution written by me. As I tell the students, I watch a lot of football. My family supports Crewe Alexandra, League One, English Football League. And I've seen a lot of people take crosses, but that doesn't mean I can take a cross. So, you know, you've got to do something yourself. So I've tried many, many things over the years. I've taught probability for donkey's years. And the trouble is, whenever I issued model solutions, because students find it hard to persevere with problem solving, because they kind of give up and they think, well, I'll just wait, and I'll wait till I see the model solution, and then I'll learn how to do the problem from the model solution. But of course, that's not really going to help them, because they may understand how that particular problem was solved, but they haven't learned anything that'll help them on the next one. So I decided this semester I'm not writing any more model solutions, and this is what I did. The students, I have about 120 students, and I meet with them in one big live class once a week, and then in groups of about 35 another time during the week. And in those groups of 35, they're divided into study groups of 5 or 6 students. That should say of 5 or 6 students. And each week, each study group has to post a model solution to one of the tutorial questions on the Discourse Discussion Board, which my colleague, Thomas Wong, who I think spoke about using the Discourse Discussion Board back in January, has kindly set up for me. Anyway, and then after they've posted their solution, the TAs and I provide feedback on the posted solution. And if there's some problems, if they haven't explained something very well, or they've perhaps kind of got the wrong end of the stick, or whatever the issue is, we can ask them to repost to improve this. One thing I should say that's very nice about the Discourse Discussion Board is that if the students actually bite the bullet and try to start learning how to write LaTeX, this discussion board allows them to kind of do it like a wiki post. But it also allows them, if they can take a picture of their calculations, to take that picture and to upload an image. But the most important thing, which took the students a little bit of time to get used to at the start of the semester, because they asked, okay, well, this is all very well good. We're posting our model solutions, but when are we going to see your solutions? To which I said, no, you're not going to see, there's nothing magic about the solutions I write. There's nothing, you can write a solution as good as any solution that I write with some support and some help. and some advice and some feedback, you know, there's nothing magical about my solutions. They're not somehow a better class of solutions. And the only other thing is, and you know, I hope that students want to do things for intrinsic reasons, not for it to always to be, you know, I'll only do if there's a mark. So this was a way for them to do the work they should be doing every week in the tutorial, post their solutions, and there are no marks for it. It's not assessed in that way. It's purely formative. Here's an example of the kinds of things that, you know, just so you can see what comes up. This is an example of the kind of thing that's a pretty nicely explained answer. They didn't start out so nicely explained, but gradually students got the hang of it. That's an example of posting a image. Here's someone who's spent a little bit of time getting used to writing in LaTeX. So you can see that looks very nice. And of course, then we can provide feedback, you know, so, you know, in some places where they just don't know very much about how to write maths nicely, we can provide some feedback, point out some things that, you know, point out that an implication sign is not actually an equal sign. I don't know whether you've seen that in work that students do, but anyway, so that's the kind of feedback that we can provide. And then the students need to know how, you know, if they get used to the idea that the only solutions they're going to see to the tutorial work is actually what's posted on this discussion board, then they also need to have a little bit of confidence about how good the solutions are. So I developed a little scorecard. You can see group 3, some of the groups need some support. So group 3 is a bit dysfunctional, and I'm having to kind of intervene and see what's happening. If it's red, it means they haven't actually done the work. Yellow means that something's been submitted, there's some feedback, there's room for improvement. That's an ongoing discussion between me and the TAs and the group. And green means, yeah, now you've got quite a nice solution there. And the reason why this is so important is the 2 pieces of coursework, written assessment during the semester, are actually then take-home assignments with similar problems to the tutorial problems. And they have access, obviously, to the course notes, to the videos, to whatever, but also to the solutions on the discussion board. And so if they want to sort of think, well, you know, is there some way, something on this discussion board, you know, think about those solutions, and they need to be confident that those are good solutions. How's it going? Quality of the submitted solutions has improved over the semester. And the students are beginning to are learning to trust their own solutions, you know, because they're, you know, part of it is, you know, as I point out to them, why do they believe that when I write something down, I'm getting the right answer? Why do I know I'm getting the right answer? Because I understand at every step, you know, okay, this follows from independence. This is the partition theorem, blah, blah, blah. Once they get used to that themselves, it means they will also have confidence in their solutions. Some students are writing and editing in LaTeX, and everybody benefits from reading the feedback on the submitted solutions, because then we can discuss some other more subtle things, and the submitted solutions become the springboard for me to discuss some other things with them. They have a better idea of what I'm going to expect from them on the written assignments. I've had 1 written assignment so far, and generally I would say this year the submissions have been better than they were in past years, because although I banged on about this, and you can now tell that I'd be the kind of person who would bang on about it, although I banged on about it every year, they didn't, and had other ways of trying to get them to understand what we're looking for in terms of explaining what they're doing. Then they'd get very surprised when they wouldn't get full marks on, you know, I'm not interested in somebody just scribbling down something on a piece of paper and happening to compute the right probability. I want to know, why is that the right answer? So I'm getting, now they understand that's really what this is all about. And the intangible benefits, I think, is getting over some of the fear of doing things, of the fear of the unknown, the fear of looking at a problem and maybe not knowing exactly where to start, and then discovering that in fact you can work it out. Challenges, well, it does require time. The feedback and the facilitation requires time. I'm lucky I have a couple of PhD students who help me with this. Some of the study groups are dysfunctional and they need some support and scaffolding. This is the first time I've tried this. I think if I did this again, I think, and I kind of just jumped into it. If I was doing it again, I'd think about how to head off some of those problems. You need to support the TAs too, because the TAs are just PhD students and they themselves are learning about learning and teaching. And I have to make it clear to them what it is I'm looking for in these solutions that goes beyond just can they do a calculation. And I wish the discussion board, I wish that I try to encourage the students to ask wider ranging questions, more open-ended questions about the course or the notes or the videos or whatever. They're not so engaged in this. I have to set up the threads, tutorial 7, question 1, post your solutions here. And there's a few students who've kind of begun to interact that way, but these are only first year students. They're just getting used to life in university, but maybe not. Okay, would I use this approach again? Yes, I would. I would probably think a little bit about how to make some things work a little bit better. Like I said, how to head off a few problems with the dysfunctional groups, how to, all of this. I've learned a lot actually, and I should have said at the very beginning, thank you for letting me talk. I've just launched into this, but this has been great. This session has been great. I've learned a lot from all of the talks today, and every Talmo event I've managed to be able to attend. It's always been good. And there've been a number of ideas here about getting students, the challenge of getting them, whether it's online or whether it's physically in person, getting them to really kind of work together. The study groups that I have that are working well are beginning to understand the value of having just a little group of people to talk to and say, how do you do this problem? Or did you get that one? Or can you show me this or whatever? But it takes a long time for them to break down all of their fear of, someone will realize I don't know what to do, and they've got to get over that. We've all got, sometime in our lives, we all had to get over that. And so I would be thinking, I think I'd try to take away a few of the things that I've been made to think about during this afternoon session, talk to some of my colleagues. I'm very lucky with Thomas Wong and Pamela Doherty that I've got great colleagues at Heriot-Watt, and thinking about some of those things to just make the community and the interactions work a little bit better, and to help people be a little bit braver about doing mathematics. Thank you very much.